So we're talking about finding all the zeros of a polynomial. Finding all the zeros of a polynomial. And again, this is sort of the reverse version of what we've done to in the last assignment, right? Last time, I gave you the zeros. We were given zeros. I should say given zeros. And you made an equation. Last time you were given the zeros and you made your equation, right? You said that x was equal to, let's say, -2 or 2i or -2i, and you from that made your equation y equals a bunch of parentheses, and you went that into a polynomial, x to the third power plus ... etc., right? That's what we did last time. Given some zeros, you write your parentheses from those, and then you multiply them, and you get your equation. What we're going to do this time is backwards. Given the equation, I want you to find the zeros. Right, so if I give you y equals x to the third power plus ... I want you to be able to tell me that x equals -3, say 2 plus 4i and 2 minus 4i, or whatever your zeros are. Given the equation, how do we find the zeros of that formula? And there are lots of tools that we have, lots of tools to do that. Lots of tools do this. And we're going to employ all of these tools. We're going to use all these tools to figure out what the zeros are of these functions. So I'm going to show you how to use these tools. We have lots of tools. That word is tools there. Tools. Lots of tools to do this. So how do we start with an equation? How do we know what the zeros are? First tool, easiest tool, is graph it. If we graph a polynomial, we can see where the zeros are. And if we get one at like 4 or 1 or -1.5, -1.5, we know that the zeros are going to be in those locations. We know that the zeros are 4, 1, and -1.5. The graphing is really easy. If you graph it and you find the zeros, like really nice numbers, you're done. Easiest way to do that, finding the zeros, is to graph it. Use Desmos. No one's going to stop you. Use Desmos. Graph it. Let it help you. Let it help you, for sure. Graph it. Use Desmos. Use Desmos. And that would be a really, really easy way to solve it. All right? But it doesn't always work out with Desmos. Sometimes you may get an equation, may get a graph, where the graph maybe has something like this. And maybe your 0 is something like negative 2.6153 ... right? Maybe your 0 is not a rational 0, or not easy to find, not easy to ID. Or maybe it's imaginary, right? Imaginary zeros. And you can't tell what they are from the graph. If you can't read something, let me know. Imaginary zeros. Imaginary. So sometimes the graph is maybe like somewhat helpful, but not like fully helpful. Maybe we know what one of the zeros are, but we don't know the others. So what other tools do we have to solve this? What other tools do we have to figure out these zeros? Well, another tool is we have synthetic division. Synthetic or long division. And what synthetic or long division does is, if you know one zero, if you know one of the zeros, you can simplify the equation with division. You can simplify the equation with division. And what it does is it reduces the exponent. Reduces the power, or the exponent, of the equation. An x to the third power, it would become an x to the second power. Or if you had an x to the fourth power, if you did a division, it would become x to the third power. Then you did another division, it would become x to the second power. So every time you do a division, every time you do this synthetic or long division, your answer gets one exponent less. And so you break it down, you break it down. It reduces the exponent of the equation. So if you have an x to the fourth power equation, you do a division, it becomes an x to the third power equation. And if you do a third power equation, you do a division, it becomes x to the second power. And you can keep doing these divisions to find the zeros. And this will help. So graphing is very useful, but sometimes graphing doesn't give us like an exact answer, or we can't find it out. So we can use synthetic and long division to simplify our problem a little bit more. Another tool we have is that chart that we made. Right? We can sort of identify what possible zeros we're looking for. Right? We have our real and our imaginary, our rational and irrational roots. And the chart says the total number of zeros has to be equal to the degree. So if I have, let's say my equation is if I have a y equals x to the third power, I know that my zeros, I have to have a total of 3 zeros. Maybe 1 is rational, 2 irrational. Maybe they're all rational, maybe there's no imaginary, right? Maybe 2 imaginary, 1 it's various combinations of this chart, right? So I can have like 1, 2, and none. Or I can have 3, 0, 0. Or I can have 1, 0, and 2 here. That's a 1 over here. Right? We talked about these different combinations you can have of these zeros. And so this chart can help us to identify the helps ID the possibilities. So we're looking, so we know what zeros we're looking for. Are we looking for 1 rational zero and 2 irrationals? Are we looking for all rational zeros? Or do I have only 1 and are the other 2 imaginary? So it helps you to identify what you're looking for. And check off, do I have all the zeros? Did I find all the pieces I need? Am I missing an imaginary? Do I have only one of them? Do I need to think about the pair? Right? It helps you to identify what you're missing and what you need to find. So this chart helps you kind of like clarify what you're trying to find. And the last tool that we're going to use that's very helpful is a tool from long ago, Quadratic Formula. The Quadratic Formula is going to help us find any of the complicated, irrational, or imaginary zeros. Really, it helps us find all the zeros, but especially the irrational and the imaginary ones. It's the sort of I don't know. It's like a hammer. It just does the job automatically. Helps to find complicated zeros. I should say helps to find any of the zeros. Helps to find any missing zeros. Under the chart, it says helps ID the possibilities. Possibilities. Helps ID the possibilities for the zeros. For the zeros, I should say. For the zeros. What possibilities you have, right? What you're missing if you're making sure you have all this. And the last tool, our Quadratic Formula, it helps to find any missing zeros. It's like a hammer. It will, aka the hammer. It's going to help you solve any of your last zeros that you find. Okay. But, there's always a but. But, it only works on x squared equations, on quadratic equations. But it only works on equations that have x to the power of 2. We want to be able to use this quadratic formula. We want to help find any missing zeros, but we have to get it so we have an x squared equation. And so the quadratic formula ties in with this synthetic and long division. Every time we do long division, we reduce, reduce, reduce. Once we get to x squared, then we can use this quadratic formula. And that'll help us to break apart any last zeros and find any missing pieces. And just in case you forgot, here's our quadratic formula. It finds the zeros. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And this is for equations that are like y equals a. Let me do this. It only works on equations that are like this. Y equals a is the number that's in front of x squared. B is the number that's in front of x. And C is the number that's by itself. So you have A, B, and C here. It only works on equations that are squared equations. So what we're going to do, our strategies for finding the zeros of equations are, we're going to start by graphing, see if we can find a zero. If we find one of the zeros, we do some synthetic and long division to break it down, to reduce the power down to a squared. Once we have the squared, we can check our chart, make sure we're doing it correctly, and use our quadratic formula. Once we have the squared problem, use our quadratic formula to find the last missing zeros. They're going to be irrational or imaginary. We can check our chart for what those are. So that's our strategy, all right? First, use the graph. Find the zeros. Once we find a zero, do synthetic division to break them down. Third, once we get the squared power, use quadratic formula. And 4, use that chart to make sure we're locating all the zeros, we have all the pieces we need. So this is our goal. This is how we can find, given an equation, we can find any zeros of that equation using these tools. Graph it, break it down using division, graph it. Once we have a zero, break it down using synthetic and long division. Once we broke it down all the way to the squared power, use the last ones to find the quadratic, the missing zeros. And we can have our chart to verify that we're doing it correctly, that we have all the powers. Questions, folks? Should we do some examples? Let's try these out. Let's try this. Let's try doing this for an equation. For example, let's give you an equation here. What's a good one? Let's say I like. There's a good one over here somewhere. Where did you go? No, not you. Not you. Where'd that one go? Okay. So, for example, find the equation, find the zeros of y equals, let's say it's going to be x to the third power minus 8x squared plus 22x minus 20. Plus 22x minus 20. Find the zeros. I know that this equation, it must have how many zeros? How many complex zeros must this equation have? How many zeros are we looking for? We're looking for the zeros. How many zeros do we have? Good, we're going to have 3. Must have 3. Because our degree is 3, we're going to have 3 zeros. We can imagine our chart, right? We can think of the chart, and we can say, well, I can have all 3 rational. Maybe they're 2 imaginary, 1 rational, maybe 2 irrational. But I have to have 3 zeros for this equation because my degree is 3. There's going to be 3 x equals 3 things. X equals something, x equals something, x equals something else, and x equals a third thing. I'm going to have 3 zeros for this problem. My question is, what are they? Right? The zeros are the places where it crosses the axis. So, my first job is to graph it. I want to graph this. Step 1, graph and see if the zeros are easy. Graph and see if the zeros are easy. Step 1. So we're going to go to Desmos. We're going to graph this equation. Let me go to Desmos. Desmos, graphing calculator. Okay, let me share this calculator screen. Hold on, where'd it go? All right, so go into the calculator, type in the equation. We had y equals power of 3 minus 8x squared plus 22x minus 20. So here's my equation. All right, looks interesting. It only crosses 1 time. But it's a very convenient easy 0. My 0 is at 2. The other equations, the other ones, I don't see anywhere. So I'm going to have to start with this 2, and from here I'm going to have to break down and see if I can figure out what the other zeros are with this starting number. I only have 1 0 right now. I need to find 3. Maybe this 2 is a double root or a triple root. Maybe there's some imaginary roots over here. I don't know. But I'm going to start with this 2 and figure out what the other roots are using some of the tools we have to break it down. All right, so I have 1 0, my x equals 2. Let's go back to our notes. So we graphed it from the graph. I know x equals 2 is one of my zeros. So I have x equals 2 is one of them. What I need to do now is the only other way to find these zeros is I need to take this first zero and simplify this equation, break it down using synthetic division. That's the only way I can do this. The only tool, I need to use the hammer. I need to get to the hammer. And I need to get to the hammer by reducing the power from 3 to 2. So I need to use synthetic division to simplify the equation. Oh my goodness, to simplify the equation. So synthetic division, let's do a little review of synthetic division. I have my little box, line down here. And the way synthetic division works is I take all the number parts here, right? My 1 that's here, the -8, the 22, and the -20. I put all my coefficients up here. So that's 1, goodness gracious, 1, -8, 22, write this like a number, 22, and -20. Okay? In the box, I start with my first zero that I found at 2. I leave it as a 2. I'm not taking it out of a parenthesis, so I don't change the sign. I use the 0 here. Use the 0 that we found as the first piece to break apart this this polynomial. So how do we do synthetic division, everybody? Who remembers? First step in synthetic division. Anybody remember? Coefficients. It's been a while. Coefficients. Destiny got it. Bring down the first number. Yes, very good. Bring down the 1. Drop it straight down. I have a 1. So I threw away all my variables, right? I threw away all the variables, just have the coefficients. I bring down the 1. And then what? Multiply and add. Very good. Take the 2, multiply, times that, right? Times it, multiply. 2 times 1 is 2, and put it up here. Ooh. 2 times 1 is 2. Put the 2 up here, and then add. Multiply and add. -8 plus 2 is -6. And I keep going. Multiply. 2 times 6 is -12. -12. And add. -22 plus -12 is going to be +10. +10. +10. Multiply 2 times 10 is going to be 20. Add those 20 and 20, I get a 0 here. And this here must be 0. Must be 0. If it is not 0, you have done something wrong. If that's not a 0, you've done something wrong. Check your math. Check your equations. So we use our first 0, found that first 0, did some synthetic division, and we got our answer here. These answers here, the 1, the -6, and the x, I take these coefficients and I make my new equation. Make, put it somewhere else. This becomes my new equation. Put back the x's. Oh, God. Put back all the x's. I don't know why this is being so slow. Put back the x's. And create your squared equation. We started with a cube. We started with the power of 3. Started with our cube here, right? When you did the division, it reduces the exponent by 1. So this was a power of 3. All these ones had x power 3. This starts out with x to the power of 2. And so we're going to say, okay, now I have 1 is 1x squared minus 6x plus 10. And so I have my new reduced equation got a little bit smaller. It was a third power. Now I have a second power. 1x squared from this, right? 1x squared minus 6x plus 10. So I have my reduced exponent, right? We had a third power. Now we have a second power. We found one of our zeros. Now we have the other two zeros trapped in this new equation, this sort of simplified equation. The other two zeros are in here, this squared. It's the same zeros. It's reduced. And now that it's my squared power, I can use the hammer. Use the quadratic formula to find the others, to find other zeros. Other zeros. I can use my quadratic formula to find these other zeros. So I've got my quadratic formula. X equals negative b plus minus square root b squared minus 4ac all over 2a. And now I have to plug in my a, b, and c. I know that a, b, and c are here. A is 1, b is negative 6, and c is 10. A is 1, b is negative 6, and c is 10. So I just take those and plug them into my quadratic formula. Solve our problem here. Ooh. So I'm going to get this equals negative, what's my b? B is negative 6. So plug in the negative 6 there. Plus or minus square root of negative 6 squared. Make sure you're using parentheses all over the place. Negative 6 squared minus 4 times a times c. This is 4 times 1 times 10. All of that in our square root. All of that divided by 2 times a, which is 1. So we're just going to simplify this, multiply these together. Negative negative 6 is negative becomes this becomes positive 6. So it's 6 plus or minus square root of 36 minus 4 times 1 times 10 is 40 over 2. Okay, keep going. That's going to be 6 plus or minus square root of 36 minus 40 is negative 4 over 2. Right, because 36 minus 40 is negative 4. Now, what do we notice about this situation that we have here, everybody? What's special about this square root? What's the square root of negative 4? What's the square root of negative 4? What's special about something with this negative here, the square root? Something about a square root and a negative. Close, Nomi. It is an I. Yes, it's 2i. Because we're doing, yes, square root of a negative is imaginary. So we know now this tells us that our root is imaginary. Imaginary. And the square root of 4 is 2, and the square root of negative is I, so it's going to become 2i, not 4i, because we do the square root, right? We do the square root just like we would a regular radical. So this is going to become 6 plus or minus 2i over 2. And this is why imaginary roots always come in pairs, because the plus or minus here. In the quadratic formula, this plus minus means I have one positive root and one negative root. With imaginary numbers, we always want to be able to separate these into our positive or negative version. So we have 6, well, even before that, let me stop here. Let me simplify this even more. I can do a division. I can take this this 6 divided by 2 and 2 divided by 2. I divide both of these by the 2 here. 6 divided by 2 is 3. 2 divided by 2 is 1. So if I break this apart, really what I'm going to get is 6 over 2. 6 over 2 plus 2i over 2. And then I'm going to get 6 over 2 minus 2i over 2. Which means my answers are 3 plus I. Oh, God. 3 plus I. And 3 minus I. And these are the other two roots. Oh. These are the other two zeros that I find with this quadratic formula. So we found all 3 zeros of this problem. I found my real root, the rational one, the regular root from the graph. I had one easy root. And these other two roots, these imaginary roots from the quadratic formula. Right, we did our synthetic division. In order to use this quadratic formula, I had to use my synthetic division, right, to break down the bigger cube equation. I had to break it down into my squared equation. I used the 0 from the graph, did the coefficients, did my synthetic division, found my new equation. Here's my new equation. Squared equation, one less, right? We had a cube, started with the third power, new equation is the second power. And since it was my second power, I could use the hammer, break out the hammer, break down the quadratic formula, and get my other two imaginary zeros. They turned out to be imaginary. using that quadratic equation. This is 2i, everybody. That's 2i. And that's negative 2i. So 3i and 3 minus I, 3 plus I, 3 minus I, those are my other two zeros. So go back up here. One of the zeros was 2. One was 3 plus I, and the other was 3 minus I. And those are the three zeros that I have from this, the answer of this equation. The three zeros of this equation are these three ones right here, found by doing these tools here. Easy, right? You're all experts now. A plus 100%. Any questions, or would you like me to do another example? Should we do this one more time? One more time, see the graph, see the situation, see how it arises. Let me see if I can find another example here. I want to do one that's all rational, or has all zeros. Let me see. Let me try to find one that is worth doing. Okay, this is pretty good. No, not that one. No, not that one. What's a good one, everybody? No. I'm trying to find one that's not too crazy. No, don't like that. All right, let's try this one here, maybe? Hold on. All of these ones are so complicated. Okay, here's a good one. Let's try this one. I might need to go to, I don't know how much room I have. Let's try this in the room I have here. So next one, let's do another cube example. Sometimes you'll have to have a fourth power, and you'll have to do the rational zero, the synthetic division twice. But let me do a normal one here. Let's go with x to the third power. Whoa, x to the third power. Hold on. X cubed minus plus 4x squared minus 5x minus 20. There, that's a good one. Find all the zeros of this. Zeros of this. I've got 10 minutes. I can do this in 10 minutes. So first step one is to graph it and see if any of these zeros are easy. Graph and find the zeros you can. Find the easy zeros. I hate how this is slow. Graph and find the easy zeros. So x cubed plus 4x squared minus 5x minus 20. Let's go to our Desmos graph. And see what we can find here. So I said x cubed plus 4x squared minus 5x minus 20. Yeah? All right. So I've got some zeros here. Maybe they're all really easy. Maybe my problem is done. If I got a 1, a 3, a 5, I'm done. This one, though, that's negative 4. That's great. But look at these other two. Some kind of crazy decimals. So this one is great. I got my easy 0 here done. But these other two, not so useful. These are going to be irrational zeros. Obviously, right? Because our graph, there's no solid decimal. This one is going to be our rational. So we're going to use the negative 4 as our starting 0, and then we got to use our quadratic to find the other two. So we'll use negative 4 to do our synthetic division, and then these other ones we'll have to work out later. So when you have a graph like this, right, that's what you notice. You notice you find the easy one, the other ones you deal with the hammer. You let the hammer deal with those. Okay? Let's go back to our notes, finish this up. 0, x equals negative 4 is my starting 0. That's one of my answers. And I use that in the synthetic division. Do synthetic division so we can break this down from a third power to a second power to use our quadratic, right? We're trying to reduce it. We have a cube, we want to get squared. So we're going to do our synthetic division, make our little box, put our numbers 1, 4, negative 5, negative 20. Right? Take all of these coefficients, here, 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 and here. Put them into our equation. Take the negative 4, put that in our situation there. Right? Take the 0, put it here. And then do our synthetic division process. Drop down the 1. Negative 4 times 1 is negative 4. Oh, that's interesting. That's a 0. 0 times 4 is 0. Minus 5. Negative 5 times negative 4 is positive 20. And that becomes a 0. So we're good. Remember, we had to be a 0 down here. Our last number had to be 0 in order to for this to work. If it wasn't 0 here, we did something wrong. We got to figure it out. So now I take these numbers here. This is my x squared piece, my x piece, and my number part. So my equation becomes 1x squared plus 0x, that's interesting, minus 5. And then, part 3, I use the quadratic formula. X equals negative b plus minus square root b squared minus 4ac all over 2a. Everyone's favorite part. In my problem, I know that a is equal to 1. Here's a. B is 0. That's okay. Totally fine. C is negative 5. B can be 0. I don't have a problem with that. Oh, now we're at the end. I knew this was going to happen. Let me go over here. Find your quadratic equation. X equals negative 0 plus or minus square root of 0 squared minus 4 times 1 times negative 5. All over 2 times a is 1. Plug in your numbers for A, B, and C. Solve your quadratic formula. You're going to come across different situations where things are going to be 0. That's okay. If it's 0, it's 0. 0 plus or minus 0 squared is 0. 4 times 1 times negative 5. Negative 4 times negative 5, that's going to be positive 20. So this is going to be 20 in here over 2. So I'm going to have plus minus, I'm going to drop the 0, square root 20. How do I break down square root 20? That's going to be, if you remember how to break down square roots, 20 is 4 times 5. 4 times 5. And 4 is 2 times 2. You look for pairs, right? So I can bring these 2's out of the problem. Becomes 2 square root 5 over 2. And so I have my two answers. I have 2 root 5 over 2, or negative 2 root 5 over 2, which I can simplify to be just square root of 5 and negative square root of 5. And my 2's can cancel. And so there are my other two zeros. Square root of 5, negative square root of 5. So there you go, everybody. Finding all the zeros of this one. We got negative 4 is one of them. So for the zeros, we got x equals negative 4. X equals square root 5. Oh, God. Square root 5. And x equals negative square root 5. Those are our three zeros for this problem. Negative 4, square root 5, and negative square root 5. Questions? So you graph your problem. You start with your graph, see where the zeros are. If you have an easy zero, great. Use that to start. Do your synthetic division. Do your synthetic division part. Once you do your synthetic division part, you get your new equation that's a squared, hopefully a squared. If it's not squared yet, if it's still cubed, then you repeat the process. You graph again, you find your next zero, and you do it again. You keep repeating until you have a squared equation. Keep repeating until you have the x squared. Because you can only use this hammer, you can only do this quadratic formula with a power of 2. So if you don't have a power of 2, let's say your starting equation was a power of 4. You would do the graph, find the zero, do the division, you'd get a power of 3. And then you go back, you do the graph again, find the next zero, do the division, then you have a power of 2. You keep going until you have the squared. Once you have the x squared, do the quadratic formula, find your last zeros. Another little trick here, I could have said, okay, well, I could have done this. I could have said, well, x squared minus 5 is my equation. I would say, well, what if that equals 0? If I add 5 to both sides, look at this little trick here. Add 5, add 5. X squared equals 5. If I did a square root of both sides, I would get x equals plus or minus square root 5. So this is another way to do it, a little trick. Not very often. It only was possible because we had a 0 here. But sometimes you can solve the equation another way. All right, your homework. Your homework tonight. You're going to try, whoopsies, you know the way around. You're going to try these. Your homework is, let me go back to the top here. Your homework is page 144. This is page 144. Numbers, what did I say? 29 to 36 odd, and 59 to 62 all. Oh, goodness gracious. 59. This is going to be up on Schoology, so you can check it there. But good job, everybody. Thank you very much. I will post this up on Schoology. This is due on Friday. I will see you all then. Say goodbye in the chat. Once you say goodbye, you're free to go. Thank you very much, everybody.